Hi everyone, this is Richard. In this video, we're going to go over async and futures versus parallel programming one more time. The reason I'm going over it one more time is because I messed up on this again, because I confused the two, and I want to make sure that you're not confused like I was confused, because this came up just a couple of days ago. And so I needed to clarify this before I go to the next issue, okay? I went through my previous video and it wasn't exactly clear. It made sense at the time, but I want to be 100% this time around, okay? The best way I could say with async and futures is you do something and you want some value sometime in the future, all right? Parallel programming is you're doing multiple things at the same exact time, but it's a little, but there is some overlap inside of there. Let me give an example. The first example I gave in the original video was like having 3 children, and that kind of confused it more than anything else for me. Let's do this one. So I want to go to dinner with 5 friends, okay? Numbered 1, 2, 3, 4, 5. And I have 3 choices for dinner, and this is all they get, okay? The choice. You can have chicken, beans, or fish. Or why not have cake? But, oh, well, it's too late. I typed it already. So one of those 3 choices. So what I end up doing is calling each one, and nobody's home. So I leave them a message. Hey, number 1, please call me back. What is your choice? Hang up, pick up the phone, call number 2. Please give me your choice. Hang up number 3 and keep going down the line till I reach number 5, okay? Then I sit and wait, and then they call me back. And let's just say the first person to call back is number 3 and says, hey, by the way, I want fish. Okay, thank you. Then the next person to call back is number 1, and they say, I want chicken. Then I said, thank you. And then the next person to call back is number 4, and then number 5, and it keeps going on, okay? So in that way, we're doing multiple things at the same time, but not really, right? Because between each phone call, what are you doing? You're waiting. You're just sitting there. You're not actually busy doing anything. What you cannot do is you can't take 2 phone calls at the same time, but we're not doing that because they're calling at different times, right? So this is an example of an async or a future. It's asynchronous because it's going it's in different order. It's not the 1, 2, 3, 4, 5 order, right? It's a different order than that they called in. And so the future that is returned, the value that is returned, is not in the same exact order. But at the same time, in between each message and phone call, I'm just sitting around. Now, contrast that to like parallel programming itself or multitasking. Now, what is, say, for example, everybody was home and I call them up and I start talking to them. So I call up the first person and I say, hey, what do you want for dinner? And they say chicken. Okay, thank you. Then I call up number 2 and they say, oh, I want beans. Oh, and by the way, did you hear what happened to Mr. and Mrs. Smith? And oh, I had a great day because I went down the store. And so you're on the phone with number 2 for the next like 3 hours, okay? Because they're telling the story and it goes on and on and on, right? While you're waiting there, you can't do anything, right? So this is blocking, isn't it? You're actually waiting for number 2 to be done before you can go 3, 4, and 5. You can't even start those. But what's the difference here? Number 1, yes, you're going in order itself, but number 2, you're, as opposed to the previous scenario where basically they called back at different times, you were just sitting and waiting in between. Here you're actually busy. You're actively listening and you're on the phone and your time is being tied up. Yeah, sure, you can surf the internet and stuff in the meantime, but with respect to this particular task, you're just actually sitting on the phone listening to this person. So the problem with it is you're doing something at this point in time, so you can't wait for something else to actually happen, right? So that's why this is actually blocking. It's not because of anything else. You're not waiting, sitting in there saying, no, I can't take any other phone calls. You're actually in the process of doing something. So Dart is what we call single-threaded. And I have to be reminded by that a lot. It means you can only do one thing at any given time. When you're doing an async and futures, you're still doing one thing, right? You're waiting. This person calls. You answer the phone. The one thing. Hangs up. Now this person calls. Tells you they want beans. hangs up. So you're still doing it's in a different order, but you're only doing one thing at a time. As opposed to the parallel when you're on the phone there, and let's just say you're on the phone with this person and you want to do parallel programming with your other phone, you got another cell phone in your pocket, you call number 3. And then they're talking to you and they tell you a huge story itself. Then you have 3 phones on you, but you will put one on speakerphone and the other you put on your left ear, and on your right ear you put this phone and you start asking them. So you're doing multiple things at the same exact time. But so that's parallel programming, and that's not what we're going through, but that's just the difference between the two. And that's why in I think the video, a couple of videos before this, I gave a bad example because the way in which I was providing a latency was a for loop, and the system was just counting. The problem with using a for loop is that it's a calculation, right? It's actually making the computer count. The system is not actually waiting, it's actually busy. And so when the system is actually busy doing something itself, it has to be blocking by definition because it's in the middle of doing something. And has to finish that doing something before it goes on to the next thing. Okay? So I hope that's clear. The difference between waiting for something, which is an async in a future, and doing things in a different order because you're still waiting between each task, and actually doing something and being really busy in the meantime, and that's why you can't go on to it. Let's just say you're calculating some, like the 10 trillionth digit of pi. If you're trying to calculate a really, really complex thing itself, then this process is going to hold everything up. All right? We'll show an example in the next 1 or 2 videos to clarify that. But again, this came up, stumped me again, and so that's why I want to bring it up as a separate video. Thank you.